All right. The last lecture that we're going to talk about here for this unit is metals, nonmetals, and metalloids. And we know what metals are. We've seen a bunch of them in our lives. We've held them in our hands. We've used them. But just the generalized definition. Metals are elements that conduct electricity and heat. They're ductile, which means we can draw them into a wire. They're malleable, which means we can pound them into a sheet, usually. And they're mostly solids at room temperature, excepting mercury. Gallium is a metal that's got a really low melting point. It actually melts at a temperature close to the human body, which is kind of fun. And again, metals have low ionization energies because they like to give away electrons, and they tend to form cations as a result. Not tend to, most of them generally do form cations. Now, the reactions that metals have are super important in our planet and super important around us. Okay, so most compounds containing metals tend to be ionic in nature, which means they're made up of a metal and a nonmetal. So when we say that they're ionic, that means that we have a metal combined with a nonmetal. So it's usually a metal and a nonmetal, which is okay. Now, one of the most common reactions that we have is a metal reacting with oxygen to make what we call an oxide. And so in this case, this is nickel, this is oxygen, and we made nickel oxide. Nickel 2 oxide in this case. And so that's what's going on. That's that reaction. Another common one that happens all the time is iron as a solid plus oxygen makes Fe2O3, also a solid. So this is a gas. This is rust. So any of you that live in Wisconsin and drive an older car have seen rust on it, and that's a very, very, very common metal oxide that causes all kinds of problems in the automotive industry. Now, why is this important? Well, our atmosphere is large. It's got a really, really, really big chunk of oxygen as its percentage, and so oxygen chemistry happens all over the place, and so we just have to be prepared for it. Okay. Now, when we take these metal oxides, when we throw them in a water solution, because we have a lot of water on our planet, they end up making basic solutions when we add them to water. Okay, so if I take a metal oxide plus water, we get a metal hydroxide. So sodium oxide plus water makes sodium hydroxide. Calcium oxide plus water makes calcium hydroxide. And so why is that? Well, it's because this oxygen, this O-2 group in the aqueous phase, attaches a water molecule or attacks a water molecule. It kind of rips it apart, and it makes two hydroxide molecules. And hydroxide molecules are what make basic compounds, basically. And so that's an important set of reactions that we need to be aware of and take advantage of and use if we need to. Okay. Now, nonmetals. Nonmetals can be solids, liquids, or gases at room temperature. They generally have lower melting points. They generally form covalent compounds with one another. They generally gain electrons in their reactions because of their high electron affinity. So they like to steal electrons from metals, and that's usually what they do. And usually they gain enough electrons to fill their outermost p orbital or p level electron shell. An aluminum with a bromine is going to make aluminum bromide, 2AlBr3. And so the aluminum lost electrons, the bromine gained electrons, and so that's what we happen. And so most nonmetal oxides are acids, and so if they're opposite, a metallic oxide is basic, a nonmetal oxide is usually an acidic solution. And so carbon dioxide plus H2O makes carbonic acid. This is the end of that reaction. This happens every single time you open a soda pop. Every time you open your can of Coke or your bottle of Diet Coke or whatever it is you're drinking, carbon dioxide and water, they actually put extra carbon dioxide inside that solution to get just the right amount of carbon dioxide or carbonic acid inside that solution when you pop the top on it, so it becomes exactly what they want you to drink, which is kind of a neat thing. So that's a pretty common chemical reaction that we see in everyday life. Similarly, if we take phosphorus P4O10 tetraphosphorus decoxide and we dump it into water, we would make H3PO4, which is actually phosphoric acid. And so, again, that's an example of a non-metallic oxide and water making an acid. So that's a pretty common reaction. We probably need to make sure that we understand that too. Okay. And the last thing we're going to talk about are metalloids. And metalloids are just elements that have properties of both metals and nonmetals, but they lack properties of one or the other. Metalloids are kind of a mixed bag. And so several of them have been used in the electronics industry and are in high demand because of the specific properties in electrical circuits. Silicon is probably the most commonly used. And so silicon is actually used in a lot of chips inside your computers and inside your smartphones. Their electrical resistivity changes depending on the conditions around it, and so that has been used in circuitry and switches, and probably is one of the reasons that we are the technical society that we are nowadays. So, but that's metalloids. That's pretty much all I got to say. So thank you. Bye-bye.